Okay, time's come for us to move on in our conversations, and what I want to do is I want to address this idea of Address Resolution Protocol, or ARP. And what we'll do is we'll move on. This isn't going to take very long at all. So what I'm going to do is, to prevent erasing the switch drawing, ultimately this section is going to disappear right here. But what I'm going to do is I want to talk about the idea of ARP, but I'm going to redraw my topology. And what I'm going to do is I'm going to need to draw a host. So what I'm going to do is I'm going to say host. And that host obviously is going to have a network interface card installed in it. And that network interface card is going to have a MAC address. In fact, we'll just call it, for the sake of argument here, so it'll be different, we'll just call it MACX. Now, what we want to do is, again, inside of this host, I am going to run an exercise where I'm going to do a ping. So let's say I'm going to ping 192.168.0.44. Now, we know all of the IP addressing that we need. We know the destination. This is the destination address where I want to send the ping. And we also know that at a logical level, this guy should have an IP address, and it needs to be in this subnet. So it's going to be 192.168.0.3. And just for the sake of clarity, we'll say /24. So this address and this address are all in the same network. Therefore, we should be able to obtain IP reachability. So I now have everything that I need to be able to constitute my layer 3 header. My layer 3 header is going to be comprised of a source IP of 192.168.0.44. Actually, no, it'll be .3, excuse me. So it'll be .3. And the destination address is going to be comprised of 192.168.0.44. Everything specified here, thus allowing me to be able to create my layer 3 header. And we know, based on the operation of the OSI model, then what I'm going to do is I'm going to pass this down from layer 3, the network layer, to layer 2, the data link layer. Now, we've already talked about here that the problem is that I need to be able to build that layer 2 header. In fact, I'll change pen colors just to keep things clear. I'll use the red. So to build my layer 2 header, I need a source MAC address. Well, I have that. My source MAC address is source MAC address X. However, we've already covered the fact that I do not know the destination MAC address. So in this scenario, the destination MAC address is unknown. However, ARP gives me the capability of being able to learn the MAC address if I know the IP, which I do. So what's going to happen is that the system is going to send an ARP request out. And that ARP request is going to be sent to, and it's going to say, who is 192.168.0.44? That's the question. However, in order to send it out, we've already said that we need to be able to build a layer 2 header. Well, what we're going to do is we're actually going to send this message to a special MAC address called the all Fs MAC address. I'm drawing it out full, and you can see it's taking a little while because it's 6 bytes of information. 1, 2, 3, 4, 5, 6. And this is called the all Fs MAC address. Now, the all Fs MAC address will be treated by the switch in a special way, and we're going to get into that right now. But ultimately what's going to end up happening is the data that I need to send, the ping is going to get parked for a temporary period of time. until such time that I receive an answer to this message, which is called an ARP request. And what I'm going to do is I'm actually going to be waiting for an ARP reply. However, in order to receive this ARP reply, I am going to be surrendering every aspect of this to the behavior of the switch and the switches between me and the particular device that I want to talk to. Later on, we'll talk about trunks and we'll talk about having switching topologies that are larger than one switch. But what I want to do right now is I want to make certain that we actually cover this concept of how address resolution protocol works. Address resolution protocol is a protocol that allows me to resolve a physical address if I know the logical address of the specific destination. And like I said, it's going to get sent out to the all Fs. Now, as a shortcut, you'll see me annotate this all Fs a lot of times just as F.F.F. All right? Technically, it should be 6 of them, but I'll try to make reference to it as the all Fs since that's the term that we started with. But if I slip, understand that's what I'm talking about. It's kind of a pain to draw out all 6 of these hexadecimal slots. But keep in mind, it's 48 bits in length. It is going to be 6 bytes. So it's 1, 2, 3, 4, 5, 6 bytes. And it's going to be subdivided such that the first half is the OUI, the second half is going to be the sequence. So I'm really excited to move on because what we need to do now is we need to look at how this works in concert with the switch, and it's going to be an ideal and perfect opportunity to introduce the concept of the intelligence capability that is actually embedded into our switches. Till then, I'm Terry Vinson, and I'd like to thank you for learning Data Center with me.